year, Kelly and I participated in what was called the AMP program. It was a conjunctive program between Rice University and ConocoPhillips, and the AMP is an anachronism for Applied Mathematical Practices.
It was an applied math program.
A math program. So that's what it was. That's us. Kelly Royce, Patty Sontag, and we're from Quest Early College High School. The goals for AMP and the intended outcomes were to increase interdisciplinary lessons between math and science, and specifically they asked for a pair of Algebra 1 and biology teachers, and they wanted to also increase inquiry-based learning. So that is where the child or student explores and learns from their exploration. And a lot of students that we get don't come from that kind of environment. They come from the worksheet world, where they hand them a worksheet, they show them how to work a problem, and then they have to do it. So in order to kind of help my students understand, I started with Snow White. And again, my goals were not just integrated curriculum and inquiry-based learning. I also wanted to employ creative thinking skills and collaborative work environment. I showed them a video from film theory called What Really Saves Snow White. You all know the story, right?
Yes,
Gets thrown out by the evil step witch, then she gets poisoned by the evil step witch, and then she gets put in a coffin by the dwarfs, and then some weird prince that has this thing about kissing corpses comes by and wakes her up, like that, right? The link is there if you want to actually watch the video. It's about 15 minutes long. The first thing that the video does is it examines the authors of the story. So the Grimm's brothers, and where they were from. So they were from a region in Europe, and they attached that as far as importance because Snow White was poisoned, and they needed to figure out, well, what were the indigenous plants or animals in that region that could be used to poison Snow White. And they came up with some culprits that they could rule out because geographically they weren't there. But they did discover a plant, nightshade, that could have been used. And so they went into the refinement of nightshade chemically, and whether it could be stabilized and used as a poison, and what the LD50 would be, and whether or not that could be effectively applied to an apple or the surface of an apple and disable a person with just one bite, because you know Snow White didn't get very far into that apple before she was out cold. They went back to historical use of nightshade and came up with Macbeth and referenced Bubble, Bubble, Toil and Trouble, where those witches were also brewing poison that ultimately killed somebody. Then they went into the sociology of work and those dwarfs, and they found out that these dwarfs were in these coal mines digging all the time. And Snow White herself is a little bit of an obsessive-compulsive cleaning woman, you know, whistle while you work. She was inhaling all those coal particles, which created a carbon-activated filter in her lungs and ultimately filtered out the deadly nightshade. And that prince had nothing to do with her wake-up call. So that's what the students got as a guide. What they got as an assignment was Snow White had already been used. What's the next most important thing to a 14-year-old's brain? Alcohol, right? So I gave them the blood alcohol formula, which is kind of intimidating. Blood alcohol percent is equal to the total alcohol consumed in ounces times the factor of 5.14 divided by the weight times the ratio for men or for women, depending on what sex they are, and times the hours of time passed since the first drink. This was the objective they were given. So it was very open-ended. Create a product that involves a study of blood alcohol content with different curriculums involved. These were some of the graphs they produced. have a few video clips. Hopefully we have enough time to do some of these. So what have you guys discovered?
I think we're doing research now.
Just doing research?
Yeah, we're doing on ground.
So what did you find out just from looking at the ground?
Male has less tendency to abuse female to be less a higher
And what do you think's causing that? Well, what if you chose a man and a woman with the same body weight? What would happen then? So one of the things that was interesting in there is that they just assumed that the body weight was the controlling factor until we started asking those critical thinking questions. And all of a sudden it was, well, what if they both had the same body weight? And there was that dysfunctional type answer, or that moment of disequilibrium, as one might want to call it. Instead.
Well, we're doing 4 different grams of Sontag, and we're doing 4 different drinks. But overall, we have the same weight, we have the same age.
So you left everything constant, and what you varied was the type of drink or alcohol
Yes.
that they consumed? And how did it impact, or did it?
Well, it did. Some drinks were lighter than others. Light beer had a lower, yes, the lowest. Sorry, for 1 hour, 0.1, but for the rest, it's 0.2 actually.
So that one was interesting because even though they didn't realize it at the time, they had identified that there were different variables that were affecting things, that were creating things to be higher or lower. And they had held everything constant except for one variable, which was mathematically was a great step for them. So what are you guys cracking on yours?
All of them comparing each other.
What do you mean each other? How do you mean you're comparing each other?
Like, we all put in our own data, and then for 6 times, like 6 shots, and then all, like, the different colors on here are different.
So each color is a different person?
Yeah. Yes.
And so that's what your blood alcohol content was after 6 shots for each of your different body weights and stuff?
Yeah.
And what kind of alcohol did you drink?
Vodka shots.
Oh, you drank vodka shots? So, the black and the green?
Yeah.
Ooh. So, what's that telling you about the difference between the impact of blood alcohol content, or how alcohol affects women versus men? If you're what?
Guys get alcohol in their system faster than girls do.
They get it in their system or out of their system? Oh, they get it out
You
faster.
can see like me and Josh know we slow. Research changes is high because they can't get rid of it as fast as we can.
So they actually had become their graphs. Those graphs were not just graphs, those were those kids in those graphs. And they also had figured out how to get their own data and organize their own data.
Yes,
Over an hour.
An hour.
Okay, and so you guys had also researched some of the side effects of alcohol consumption. What were some of those side effects?
You have short-term and long-term. Changes of biosenses, impaired drug use, vision, poor coordination, slow brain activity.
And do you remember when those different symptoms occurred or side effects occurred?
I'm certain blood,
I think he was irritated by my hammering his face and he wanted to return the favor. But, I think they're better stars than I am, so we're gonna go back to.
There you go. No. Great one. Better.
So the results that the students, this was just the mathematical part that I filmed to show the integration of the biology with the math. Their actual presentation was a video or PowerPoint or something that resembled the Snow White presentation. And what they came up with was historical and cultural uses of alcohol, regional variations of the products that were used to produce alcohol based on the vegetation, social impact of alcohol abuse, and obviously you saw some part of the discussion of the biological impact of blood alcohol levels on the human body. Mathematically, they used graphs to display data. They also gathered data, and I didn't put that on there. They had discussions about discrete and continuous graphs, and a lot of discussion about independent and dependent variables. So mathematically, it was huge, and then for the other curriculum, I thought it was great too, and I was really pleased. All of their presentations, unfortunately, are too long for you to sit through, and Kelly needs to talk.
So for my lesson, because we really had to shift our lesson, it's just a little bit more difficult because they're not at the same grade level. So ideally, we would have ninth graders in algebra and biology like they do everywhere else, and then we'd actually, be able to kind of talk about those concepts back and forth. So because I have 10th graders, it makes it a little bit more challenging, but at the same time, they can draw from the places that classes they've already been to, topics they've already seen, subjects they've already gone through. So my lesson was not nearly as exciting. We dealt with enzymes and we graphed enzyme activity. So our basic goal was we want to integrate curriculum, so I wanted to actually apply math to the enzyme section, which we don't exactly get to do as much math through that section as I would like with the time constraints. So we made time for it, and then give them an environment where they can collaborate together like they normally do. I put a little sticky note on here because this is what we actually did get to discuss. We did, in a biology class, get to talk about coordinates. We got to talk about discrete and continuous data. We got to talk about hypotheses and how they work here. We talked about X and Y values, and we talked about independent and dependent variables and how they work for what our graphs were. So that's them working together. Our objectives were they had to create a graph, and they plotted 3 different enzymes using only data. So before we actually did this lesson, we did an enzyme lab. They had beef liver. Beef liver has an enzyme called catalase. We put hydrogen peroxide in there, and it bubbles, and they got to see all these cool reactions. But now we wanted to take it to here's the math part of it, and how can we actually take out information about biological concepts through just numbers. So what I gave them was either pH or temperature for their group, and they got a whole list of data. They just got numbers. So for this one, they got the pH, whether the enzyme was really active or not. And all they got was that. And they had to graph it out and then work together to answer questions about where does that enzyme kind of live, how does that enzyme how does it work best, just given a whole bunch of numbers. So it's not clear what's going on with just the numbers, but they got to graph it. So first they started by making their own graphs and working through and kind of taking the 3 enzymes and working individually. And then I had them put graphs together, which if you want to see them, they're in my classroom stuck to tables back there. But they had to create a graph as a group. And at the end of it, they had a discussion, and this one's not very long. And I don't know if it'll play out that well, but I'll show you.
Yeah.
high. If these are high, it's like on cool. And it would be
Probably hard to hear, I didn't record all that much, they had the rest of the recording, but I kept mine short. But basically, their whole discussion was like looking at the graph and saying, okay, well, if this enzyme is the most reactive at this graph on a low pH, then that means it's gonna come from this animal's stomach, because the stomach has a low pH, so that's where it comes from. Okay, if this enzyme is most reactive on this graph at a high temperature, well, then we think it comes from a hot springs, because that would make sense that it's most reactive in an area where the temperature is high. So we had to take a whole slew of numbers and actually kind of figure out all the biological significance just based on numbers. So we got to add that kind of math component, which isn't nearly exciting as blood alcohol content and Snow White, but we did it anyway. So for our kind of overall program and the stuff that we discussed with the participants in our program is that we want to make some meaningful changes. We have a better appreciation now for these open-ended lessons, and I can show you another one that I did, but having students actually generate their own questions, having them be the inquiring minds and come up with their own generated questions that we can then test gets a little bit harder, but we can have them generate their own questions and then move our investigations in those directions. So we have a better appreciation for that. And we also have a better appreciation for inquiry and exploration. So for the inquiry learning part of things that we did, I actually incorporated one. So this semester, they have to do these presentations. If you've seen or heard about them over the years, is that they have to talk about an animal for 8 to 10 minutes. And we usually have a lot of vocabulary in that, things that they haven't heard of before, like deuterostomes and protostomes and segmentations and coeloms, which looks like a funny word because it looks like it's spelled colon. Drives me crazy. But we had all these words, and so what I did to start with is that I found a lesson where they got just a bunch of cards, and I gave them a whole bunch of cards to each group, and I say, you have the whole class period to figure out what invertebrate those belong to. And so they had a chance to explore and take those characteristics or pictures, and they'd be like, what's this? What's this? And a lot of the vocabulary that came up, so we made an unknown words board, and I would say, as you find a word that you don't know what it means, put it on the board. Either somebody else is going to define it, or I'll come by and give you some definitions, but take words that you don't know and put them up there, and let's talk about how they connect. So as we went through it, they got to sort out these words they didn't know. They looked a few things up. We wrote them down. Including deuterostomes, which just means that it develops anus first. I love that one. Okay. But we came up with a whole list of words that we don't know, and so we're actually able to investigate before we actually did the presentations. And I will tell you, this year it seems like we had a lot better understanding of these are protostomes. This is what a coelomate is. It has a body cavity, all this stuff. They were actually able to apply the words that they had used from investigating and sorting out. So it was really exciting to see that this year. We also had to discuss us as teacher leaders. We'll say that we used this for our PLC last semester, as Patty and I both wanted to make sure we covered interdisciplinary stuff. And we say that we encouraged others to join our little group, so that was us taking on the teacher leader role. We put it in there because we could. From our actual AMP program, there were some things that moved us just looking at student success. We really liked making real world connections and offering up more examples that we could make real world examples, like blood alcohol content and even enzyme function. We can sort of make that an application for real world stuff. I will say there was a really, really cool dude. He's a university professor at Royce. His name is Dr. Richard Tapia. His was really cool. He had a presentation one of the days that we were there over the summer about his kid basically, but he's a statistics guy, and he was able to apply statistics to dirt bike races to make a whole lottery system so dirt bike races would be more fair. It was fascinating, and I don't know how to explain it properly, but
the concept was the lane that you are assigned is pretty much the biggest factor on whether or not you're going to win. And so they turned it into a lottery system where you drew lanes and you automatically got assigned at least one of the lanes that had the highest percentage of success, which I think was lane
Something like that.
3 or 7, something like that. So it made it more equitable because when you multiplied the probabilities of success in each of those lanes, it kind of evened out the ultimate probability of the total wins.
It was a cool application. That's a university professor who's made this whole change. It's like how they do those races now, all of them. So it was really exciting. I just like the application of it. That was cool. So in the future, we just want to make sure that we continue to make open-ended lessons where we can have the students generate those questions so they can inquire and explore on their own, and we can do those investigations that have kind of more open ends for them to deal with. And then we want to continue to make sure that we do interdisciplinary stuff between math and science and actually incorporate math more often in my science class and have more biology components there. So we see that, you know, it's not just this class and this class and this class, but in the real world, they all kind of mix and mingle, and you got to know a little bit about everything to, you know, be able to actually investigate things. So.
Okay, so any questions?
Yes, I have a question. So I saw all the kids doing all the graphing, and I thought, hey, I teach Excel. We should, you know, work together, and how can we incorporate those graphs into the Excel program?
Well, that would actually be perfect because they could gather their data, they could put it in Excel, they could look at how to generate different types of graphs using Excel, whether they wanted to use bar graphs or double bar graphs, or in the case of the 4 different students, 4 different bars. They could use line graphs. They could examine whether it would be continuous or whether it would be a discrete type of graph and see what the difference would be.
It's like,
So-
what's the most appropriate graph
Right,
anyway for that
right.
data?
So I think it would be perfect to integrate that, so they not only would have a manual that they could generate a manual graph, but then they could see how easily they could use technology as an option to generate something through Excel.
Since we have Chromebooks available,